Hey guys, I'm Ryan. This video is kind of a follow-up to my last video in which I talked about the design and building process of the CNC router. In this video I'm hoping to go over the wiring and electronics part of the router. As always, feel free to comment with advice or questions. With that, let's get started. Like I said in the last video, I bought a 4-axis stepper motor kit off eBay from Stepper Online. Came with 4 NEMA 24 stepper motors, a power supply, 4 drivers, a breakout board, a parallel cord, and a USB cord. Let's take a look at the wiring. So after dumping my wife's stuff out, I used the storage bin as my electronics enclosure. So let's pull it out and get a closer look at it. Wire management is kind of a pet peeve of mine, especially when you're dealing with high frequencies like this. It helps when you can keep the wires as far away as possible so that no stray frequencies get into your limit switches or your e-stops and trigger them falsely. So I jerry-rigged this old power supply to supply 12 volts of DC current to this terminal rail, which then I power a 12 volt computer fan to keep some air moving, and then also to supply 12 volts to the breakout board. For the wiring diagram, I'll put a link in the description to Stepper Online's eBay page. For now, I'll show you how I did it. So real quick, right here you have your limit switch inputs. Right here is a common ground, and then I have my proximity sensor coming in as a limit switch, and then an e-stop. Along here are your step and direction pins, 2 wires per drive. Right here I have my power supply for the drives, that's 5 volts. Right here is 12 volts coming in that give the limit switches 12 volts. Right here you got 110 coming into the relay, 110 going out from the relay. That's so I can control the router from Mach 3. So different forums I read said you should use shielded wire. I used 18-4 shielded wire from my drives up to my stepper motors. I'll post a link in the description from where I bought it from. This specific wire does not have a ground wire though. It just has the coating. So it makes it a little difficult when trying to ground. So what I did was I revealed the shielding here and then pushed a stripped wire up against it and taped it really tight. Then I checked for continuity at the end of this wire at the shielding to the end of this wire. Then I tied them all together here and I met up at my common ground. So right now I have 1 limit switch set up just to test it out. I'm using an inductive proximity sensor. I'll post a link in the description. Seller was good and the product worked well. They run about $2.40. Watch when buying proximity sensors, there's a couple different kinds. There's NPN, there's PNP, and then there's normally open and normally closed. I'm using an NPN and a normally open. NPN means that it's sending out a negative signal when it's triggered. PNP means it's sending out a positive signal when it's triggered. The other thing you want to make sure of is that you're not hooking the polarity up wrong. You'll fry them really easy. You want to make sure that your positive is on the brown wire and your negative is on the blue wire, and that your signal is the black wire. Not every parallel port card will work. I bought this StarTech PCI Express card off Amazon for $22. Works really well. Alright, so before I go, one other thing I wanted to mention as far as the computer goes. I found that installing Windows XP 32-bit and then putting Mach 3 on that worked really well, made things go a lot smoother. Just my 2 cents. But again, thanks for watching. Please like and subscribe, and we'll see you next time.